My name is Seema Ramchandani. I am the Performance PM in Silverlight. And what that means is, if you're at Microsoft and your Silverlight application isn't performing as expected, I'll get an email. Today I'm here to speak about the graphics pipeline and understanding the graphics pipeline enough that you can write an optimized application. So why are you here? My guess is that at some point we've all built an application that should be simple, but for some reason the way we've used the platform, whether it be Silverlight or any other platform, graphics platform, we generally see 100% CPU, and we don't know why, and we don't know how to debug it either. Let me give you an example. When I was in the WPF team, we got an email from the demo team saying, we built this reader. All it does is display text. No animations, no scrolling, nothing. But it's taking up all of my computer cycles. The machine fan is like on high speed, and I have no idea why. There must be a bug in the platform. And so the graphics team, I was on the 3D team at the point, we just started to, we looked at the code, it just looked like spaghetti. And so it was just like debugging this just mass that we didn't know what to do with. So we removed the text, we removed the panels, and we removed everything on top. And slowly we found a giant 3D dancing bird. The demo team, the designer, had hired a designer who had thought that it would be a fabulous idea to create this 3D dancing bird, and then decided that it looked really ugly, didn't get the okay. So he stuck it back in the back of the Z order, saying, this way I can save my work, but it won't take any CPU cycles because I'm not actually drawing it. It's just invisible, right? Well, it turns out that the cha-cha is actually really complicated, and having the Peacock figure out how to do the cha-cha was also really complicated. So we were doing all these cycles of, okay, now the left step goes here, and now here goes the right step. And in actuality, we were spending all these cycles on something that had no gain to the user. So by understanding the graphics pipeline a little bit more, hopefully we can avoid these errors. But at the same time, if we do make these errors, I want to make sure that you know how to debug it. So I'm going to talk about 4 things today. Specifically, the graphics pipeline, how it works, the media pipeline, how to get the best cycles out of it, how to profile your application once you've written it, and then how to tie it back together to actually build a more performant, better application with your designer and developer team. Whenever thinking about Silverlight, think about executing code in this manner. We start with always managed code. Your user interactions will go through the control system, or maybe it will go through your own user code. It will pop down through the p-invoke layer, that yellow line, into the Silverlight native platform. Those modules will call back into and out of each other. Anytime that you have an event handler, we'll do a reverse p-invoke. So really, all you need to remember is managed code, user code, p-invokes, back and down into the native layer. The native layer can call within each other. When thinking about your user code, remember that it is executing on the UI thread, and that UI thread is shared between all plugins within the browser. And that UI thread is also responsible for your animations and your layout. So often we'll see something like a search application where they have an animation happening on the side thread and then building this gigantic tree of their search results. What that will do is both of those are occurring on the UI thread, and the animation will become jerky. So always remember, something's on your UI thread, make sure that you're not actually plugging it up. Silverlight is multi-threaded, and we do offload the frame rasterization and the media decoding. And I'll discuss both of those in detail. So when you build a Silverlight application, it always follows that pattern of that architecture diagram, no matter whether it's on Windows or Mac. You develop it once, and it runs everywhere identically. You also understand what happens on which thread. So the last thing to understand is the graphics pipeline is actually the animation loop. What happens each tick? How do we actually get things to draw? This diagram will repeat every single tick within your application. We start off with event handlers. If your user has actually interacted with the computer at all, let's say that it's hovered over a button or clicked on something, it will probably initiate some animation of some sort. The animation is actually calculated on the tick, and we identify whether any property has changed in reaction to that animation. So again, the frequency is at the frequency of the plugin's frame rate, and you have control over that. You can set it to 60, that's the default. I always suggest starting at 20 and seeing if your users notice. Our animation system is real-time based. So let's say that the UI thread gets busy for some reason. Your animation will will go back to the position where it is on that timeline, and it's not frame true, it is time true. We have three types of animations. The first one is the simple interpolation animation, point A to point B over linear time. The second one you're going to see in depth with the production of blend. Splines and keyframes are a way that a designer can actually introduce sort of a natural effect into the application where something grows suddenly and then starts actually spreading its wings out. Object animation is the ability to actually animate almost anything in Silverlight, whether it be a Boolean or even visibility. You can actually animate between the enum values. The reason why animations are so important to understand, and to understand thoroughly, is that every single control interaction is actually a storyboard. And we'll talk about that in the Visual State Manager. And Karen Corby will go into depth on that on, I believe, Thursday. But every single interaction with your user generally will be an animation of some sort. And will actually it will incur a loop of this animation loop. The property change, let's say that you actually animated visibility, like from actually collapsed to visible, or you've grown something in size, will actually incur a layout cost. When we think about layout, think about the fact that everything is nested. So a list box contains a scroll viewer. The scroll viewer contains a stack panel, which is measured at an infinity size, and the scroll viewer displays only a certain section of it. And even within that, there's a stack panel and many items. Within each tick that has caused a layout pass, we're going to walk through the dirty area for a measure and arrange pass. We'll do this twice. We'll first ask everybody how big they are, and then we'll ask the children actually to arrange themselves based on the size that they've been allotted. We now find out exactly what is dirty within the tree. And so each of those that have actually incurred some sort of change with the property have actually been marked as a dirty, with the dirty flag. We walk through the tree, no matter the complexity, to actually figure out what to draw next. So we actually have now a queue of the rendering changes that we need to make, and we need to actually compose it. And so we actually compose in a back buffer within Silverlight. We actually compose what the change should be, the diff, really. And it's one big rectangle. And then we actually present via the browser. And that's it. That's actually how we draw within Silverlight. If, let's say, that you make your application transparent or windowless, which are two features that enable you to interact more with the rest of the things on the HTML page, you will insert two extra calls within this animation loop. You will ask the browser what is behind us, and then Silverlight will ask the browser to blend us with the rest of the HTML content. So the transparent windowless plugin is actually a very strong feature. It's useful for windowless if you have any overlay that you want on top of Silverlight, let it be HTML, DHTML, or let's say Flash. Or transparency if you actually want something to show underneath through your Silverlight plugin. The reason why I discourage people from using it is because I often see people using transparency just to give rounded corners to their Silverlight plugin. And that cost of every single time we do any property change, we insert 2 steps, that's a very expensive cost. And I want to make sure that when you're building your application, you're aware of that and you understand why you should leverage that feature. So we always draw the lower layer, Silverlight will compose our own layer, and then the browser will actually do the blend. A transparent plugin will always incur this cost, be it that you have rounded corners or maybe actually animation underneath. This cost is always incurred. And every browser deals with it differently. Within IE, we actually cause banding, which is simply easily illustrated, which is normally we're asked when we draw our Silverlight plugin within IE. We are given a giant rectangle that we can blit to the screen. Here's our Silverlight plugin. Here's everything that should go in it. With transparency, we're actually asked to draw each rectangle separately. So although the transparent windowless feature is great, it lets you interact with the rest of the things on top of your HTML page, make sure you understand why you're using that feature and whether that actually is required for your design. So to get to back to the animate loop, we only redraw the dirty region and only what has changed actually on the visual tree. So therefore, I suggest avoiding large-scale animations. Large-scale animations are commonly used by designers if they want a subtle visual effect of like a slow blend or an aurora effect. And although that blend might be very subtle to the human eye, it's actually causing the entire plugin to repaint because we are actually redrawing every single pixel that is blended. So keep in mind to always keep in mind the size of the area that you're actually causing a redraw. And work with the designer to see if you can have the same visual feedback, but maybe a different effect. The third thing to keep in mind when actually talking about the graphics pipeline is that text redrawing can be expensive and can actually cause our hinting algorithm to rerun because our text system is optimized for actually legibility. And so I will talk into depth about that one later. But these are 3 things that you should keep in mind whenever you're talking about what sort of visual effects that you want in the background. When in doubt, when you're not sure exactly what's going on, let's say that you got a drop of the new design or the new UI, you can always use something called enable redraw regions. And this is a debugging setting that we heavily use internally, and it's just a way to figure out what's going on in the background. So here I've actually outputted.
I wonder what's up there.
I've outputted via the expression encoder a simple template, and I popped in the Halo commercial.
Do you think I'll read them?
What you see around is
Don't you?
we have this lovely progress bar. It will animate out. We have thumbnails, which we can scroll through, and we can select. But I have no idea how this application is actually composed. So what I do here is I go through the Create Object X. This is where I've actually created the Silverlight plugin. And I normally have the normal properties. I've set my width, I've set my background, whether it's windowless. And I can actually turn on this property called Enable Redraw Regions. And this is just a debugging setting because it's going to make things a little ugly. So what we have here is a debugging setting which will show you exactly what is getting redrawn when and where by coloring things blue, yellow, or pink. Every time I cause a redraw, I will actually see exactly what's getting painted. So notice that when I animate in and animate out the thumbs, I only see that small rectangle getting drawn, probably a little bit extra here. When I scroll through the actual thumbnails, I can see that correctly we are clipping and only redrawing that area. But notice that if I actually animate out my progress bar, I'm animating in and out a giant canvas that is invisible and actually is a cheaper cost because you're actually blending with 0. But regardless, that cost is still incurred by the Silverlight platform. So remember, when you're building your application, try to blend as little as possible in the smallest size as possible. So what's happening here is that as I animate in and out my progress bar, I'm actually reblending almost the entire plugin, and that's unnecessary. So again, a great little debug tool, Enable Redraw Regions, for you to see exactly what's getting redrawn within the application. So now we need to stitch the scene together, and we actually need to rasterize. All changes within each tick are drawn at once, at one point in time. In order to evaluate exactly what part of the screen is actually causing a huge increase in cost, you can actually max out the frame rate and see what changes your performance drastically. And I do this by maxing out the frame rate and looking at the frame rate counter. So again, another debugging tool. With this, you can actually identify, hey, that blending cost or that icon overlay, is that actually impacting the application in some reasonable fashion? Like, can I actually detect that? This is a simple way to actually figure out, as you add modules into your application, what is causing a frame rate to drop. The second thing that happens when we incur the rasterization, we actually start drawing via brushes. And brushes are a fantastic way to actually integrate the different code paths within the graphics pipeline to draw something that might be of irregular size. So solid color brush, as you know it and love it, it's very simple. Linear gradient brush, a little bit more capabilities, but basically what we're doing here is we have a texture and we're mapping points in the texture into your shape, be it a rectangle or actually a circle. Again, we allocate the texture and then we map screen positions into colors within that texture. Every time you resize a brush, we will then allocate a new texture, and that's something that you should keep in mind. So if, let's say, that you have text and you want to draw it with an image, or let's say you have a circle and you want to draw it with an image, you can use something called an image brush. And an image brush is very simple. It's just like any other brush. It's just simply a texture mapping of your image into the new position, the new geometry of either your text or your circle. What this saves you by using it this way rather than taking an image and clipping it with a circle is it saves you that clip cost. You're actually drawing that image but without incurring the cost of the clip. And it's actually, it's always optimal to save your clipping. Video brush, also a great brush. And simply what it does is it will be used when you want to point multiple elements to the same video file without incurring multiple decoding costs. So we've rasterized. And after we've done all the steps of actually figuring out what to draw, we do the anti-aliasing. Anti-aliasing should be generally something that you don't think about. We have alias rendering on the left, and on the right we have more smooth circles. The left was generated by paint, of course. It has great behaviors for vector graphics. We love it. For animation as well, also wonderful. Subpixel rendering, smooth transitions as you go, 60 frames per second. You can actually see as it draws between the different pixels. However, if you have an image and it's anti-aliased, and it's maybe at a non-integer position, we can cause seaming. So at the very top, you see an image, and this is to max out the worst case scenario. Generally, people have icons with very sharp 1-pixel lines. This is an image with just 1-pixel black lines throughout. If it's on the integer position, the image will show up sharply. If you're seeing that your image is not showing up correctly, you can actually tell because it's slightly getting soft pixel lines, because basically we've either centered the image or gotten a subpixel rendering for some reason. And we've offset it a little bit, so now we interpolate, hey, this position X, now the black pixel is between pixel A and pixel A plus 1. And so we actually blur it between the two. The way to mitigate this is by a feature called uses layout rounding. And it's new in RC1, and you actually have it available on today. So if you ever see non-optimal image rendering, you can always turn on uses layout rounding, switch from a canvas to a panel. The second place that you'll see it is actually just within your vector graphics itself. You'll see a sharp line becomes a fuzzy gray line as we interpolate it between 2 pixel boundaries. So your black line becomes half on one side and half on the other side, becomes 50% gray on the other side. Why am I telling you this? I always see people who are actually confused about why their lines are blurry or why their images are blurry. It's a simple step of anti-aliasing. Once you understand it, it's very simple to see what's causing it and to mitigate it. But without understanding it, then your graphics look a little fuzzy. And so make sure to use layout rounding. The other thing that you can use is actually to overlap edges. Our fifth artifact of anti-aliasing per object is that we can cause seaming. Basically, the calculation is we get half of what's on top and half of what's on bottom. And so basically, the background will start pushing through. And if you have horizontal and vertical lines, uses layout rounding will probably solve your problem. But if you have triangles, or if you're doing some sort of mapping, for instance, you'll often see seaming coming up. And you can actually figure that out by just overlapping the edges and growing each object by a little bit. So we've actually composed our picture now. We've gone from there's some animation to actually anti-aliasing every object and then splitting back to the browser. Let's talk about the media pipeline. When I think about media, it's often assumed that you can just drop it in. But to understand what is the least expensive and the easiest way to actually get the most performant app within Silverlight, you need to understand exactly what's occurring each frame. So every pixel, every frame, we decode, we do a YUV conversion. If you have a resize within the video, then we will do that resize, the interpolation from size A to size B of what those pixels are now that we are actually resizing the video. We do a blend if there's anything overlaying, for instance, that progress bar or maybe an icon overlay. And then we actually blit to the screen. We do this every single pixel and every single frame. And it's true, the media file might have some compression optimization so that keyframes have all the pixels and standard frames have a little bit less. But overall, you're paying this cost. So the way to think about media and getting the best media performance, you want to encode at the minimum frame rate that you need. So if you have high-quality sports video, sure, go for 32 frames per second. If you're looking at maybe like a little bit background media on the side, or maybe just a technical video on the side, you can actually drop down to maybe 20 frames per second. Encode at your desired size. The resizing is an optional step. And of course, blending is expensive because it's just an additional step that is unnecessary. So what is the least expensive? It would be to actually go through and display your video at its natural size. The last thing to remember is that when we're actually displaying video, we would prefer to get as many ticks as possible so that we can display the frame rate as good as we can. The media operation of decoding to actually drawing is quite expensive, and our audio is being decoded at the same time. And so in order to actually synchronize, we only get a couple of milliseconds where we actually allow ourselves to present a frame. The way to get the best frame rate within your application is to give the media pipeline as many frames, as many ticks as possible to actually try to present it. So in animation, you want to dumb down the frame rate and drop it maybe down to 20. For media, you want to up it to 60. So keep that in mind. From our media team, they implemented quite a few features to actually optimize the pipeline. We understand multi-bit rate decoding, and so we can actually integrate with the Windows Server multi-bit rate APIs and actually decode videos that will be adjusted to the network connection of your client. We optimize for assembly code paths. We primarily use SSE1 and SSE2, which run on both the Intel Macs and Windows. You get the same optimizations that our Windows graphics super devs can write for Windows. You actually get them on the Mac as well. And our graphics devs, one of our media devs actually invented something called adaptive sampling. Bilinear sampling has higher quality, but it's a little bit more expensive operation. And some platforms will actually choose to do point sampling instead. What he wrote was an algorithm to choose on the fly whether to use the higher quality sampling method or the lower quality sampling based on the contrast of that pixel. So in professional video, you'll generally see somebody in focus and everything else blurred in the background. So within this picture on the top and on the bottom, you'll see that he chooses to use the point sampling where the green pixels are. And he actually can detect whether it's a high contrast area and needs a higher quality bilinear sampling. And he gives you the quality of bilinear sampling where you need it, but the better perf of point sampling everywhere else. So that's a gift from our graphics devs. So now we understand the media pipeline. So what should be avoided? The one that frustrates me the most, the one that just sort of irritates me as the performance PM, is when I see people doing this, which is basically somebody accidentally in the designer slightly stretched the video. And they didn't mean to, but they accidentally caused everything to stretch and everything to reinterpolate. A more deliberate thing that people sometimes do is they shrink a video because they're like, oh, it's too costly to encode, or I don't have the source, or whatever. Let me explain to you what happens. You first start by downloading extra pixels, extra size in that video frame. Then you decode all of those extra pixels. And now that you have those extra pixels in hand, now you have to interpolate. So you actually have to figure out this pixel A, it comes from these 4 other pixels. Let me do the calculation to figure out how to draw it. And although the interpolation is great, like, we have this great adaptive sampling method, it is nowhere, it is, you can write the best runtime performance, but it's always easier to do it on the server instead. So please try to re-encode your video at the smaller size. Avoid shrinking at all costs, because it's just not worth it. So we understand the graphics pipeline, we understand the media pipeline, and we built our application. Maybe we have a giant 3D dancing bird that we don't know about, or maybe somebody else wrote an like a good chunk of the application. We don't know. We trust them, but only so much. We want to profile the application, see what's going on. So within Silverlight, we follow something called the scientific method. Do you guys remember this, 7th grade? Observe, you hypothesize, you decide how to test, and then you follow it to the dime, and then you make your conclusion. Because if you don't do it in a scientific manner, you're probably just going to end up pointing fingers and getting angry at each other. When I debug an app, whenever, I always get applications that I don't understand. There's 70,000 lines of XAML, and it's ridiculous. I'll do the following. I'll first walk through the create object X. That's the first step. Make sure it's windowless if it needs to be. Make sure there's no transparency in the background, but if there is, make sure to actually have a reason for it. Max out the frame rate. Use a frame rate counter, and of course, enable redraw regions. Those are my debugging settings. But let's say you want to actually fine-tune this a little bit more. Your animation is stuttering. How do you debug? You can use any of these 3 steps, but I always suggest going with identifying the resource constraint, going through with the scientific method. And the way to do this is actually figure out what is blocking the CPU. This is the tool that most people use when they're trying to figure out what's going on. And it gives you the great information that IE is taking up 30% CPU. You don't know why. You don't know if it's the client has 4 toolbars actually installed on their browser, or maybe it's actually the Silverlight application. Or maybe they have 5 different versions of IE installed on their computer, and they don't really understand what's going on. We have this tool called XPerf. And it was available internally for a while. And now I'm excited that it was released in May publicly so that you too can use it for debugging. It hooks into something called event tracing for Windows, which is a mechanism for actually logging exactly what method calls are made, when and where, and actually can give you a breakdown, an exact breakdown of where time is spent in which module. It will describe your unmanaged call stack. And you'll note that within XPerf, our managed code will always show up as unmanaged, the unmanaged calls within core CLR. So let's take a look at how this works. So I'm going to actually revert. Revert the change, so now that actually it draws pretty.
You ever wonder what's up there?
I have a few keyboard shortcuts, but all of the details and all the instructions are on my blog, and it's linked at the end. I don't think it's worthwhile to see you guys see me mistype paths, so I'm going to just turn it on. So here I've actually turned on the profiler. I let my application run for a little bit. And now I ask the application to actually start, to stop the profiler and merge it into a file called haylodemo.eventTracingLog. And this is going to take a few seconds depending on how long you've run your app. But the important thing here is that it's actually merging. What it's doing at this point, why it's taking some time, is because it's actually merging in the event traces into a file that we can actually view. So now I use the viewer tool, which comes with the Windows Toolkit, Performance Toolkit, which is available for download publicly. Oh. And I can use the perf viewer to actually see what's going on over time. And so this is what I get. And this is a developer tool, so there's no fanciness around it. It's actually quite unfriendly sometimes. But what you see is the CPU, exactly what's happening, the graph. You'll see a different color for every thread, for every CPU that you have. You'll see your disk interactions. IE writes HTTP requests back into the disk sometimes. You'll see the lifetime of your processes. So you'll see that I started XPerf info here and then actually started to turn off the process at the end. But the important thing that I'm going to look at today is basically the graph of exactly what's happening with the CPU while my video is being loaded. I'm going to load symbols. My symbol server path is back to the Microsoft public symbol server path. So everything that I'm doing here is publicly available today. And now what I'm doing is it's reading through that section of the CPU that I asked for a graph. It's reading through and trying to figure out exactly what module was actually taking up time at that point in time. And it goes back to the symbol server path for every single sample. I now see a breakdown of exactly how much time is spent within IE and DWM. And you'll notice that sometimes these numbers differ from Task Manager. The DWM is the desktop window manager for Vista. If you're running Vista, you'll see it. Basically, it takes up more time if you're blitting to the screen a lot, because we're in software and the window manager is in hardware. So it will be blitting back to screen. And now within IE, I can see actually the breakdown of the time that I have spent within the different Silverlight modules. And AG means silver. So AG core is actually where we spend all of our graphics pipeline. You'll see MP control, which is where we do all of our browser plugin interactions. Not a lot of work done here in this app. This is an unmanaged app, so you see a little bit of activity from the JavaScript. We use the JavaScript functionality of the browser, the JavaScript engine of the browser. And we can actually see the breakdown of the calls. Now, most of us, most even internally, we can't figure out exactly what's going on within the different call stack of Silverlight. But what we can figure out is to answer these specific questions. Xperf allows you to get exact numbers of how much time was spent in which module of Silverlight. It will allow you to tell exactly whether Silverlight is actually spinning, and then it can actually identify which layout or design is more expensive. I think common question that we incur is, you say that stretching is expensive. How expensive? Or you say that decoding I can either decode a larger video or I can decode a small video and stretch it. Which one is cheaper? With Xperf, you can actually profile and get exact numbers of what the impact of the different visual designs has on the performance of your application. And again, instructions are on my blog. So now we know how to profile the application and debug it. Let's take it back and let's actually think about how we can build a better application. No. I like the idea of little animals running around in my machine. So we create the application, we create the tree, we do the layout pass, and then we actually present. In more depth, you'll actually see the navigation. We download the HTML, we do a round trip. Think about the round trips whenever you're thinking about the startup time of your application. We'll download the JavaScript if it calls in. We create the plugin. We identify whether it's a managed application by whether the control source is a ZAP or a XAML file. And if it is a ZAP, we'll actually start launching the CLR in parallel. At this point, we actually identify which assemblies are referenced in the manifest, and we will start loading them all. They are not delayed. We then create the tree. We set our visual root and actually start building the application. If, let's say, that it's a hello world, then you're going to call in the tech stack. And the thing to remember within the tech stack is that it's largely across OS consistency, and so all of our rendering is done within Silverlight itself. And we wrote our pipeline to optimize for our legibility. So we have anti-aliasing, subpixel rendering with horizontal and vertical dropout, and of course, gamma correction. And if you're not careful, you might actually cause this to re-incur this. If you animate the text, you actually might cause the text to actually redrop. But the good news is your text will look really good while it does this. So we have the translation of text will actually sometimes cause the subpixel rendering to change, and so we'll do a little bit of re-rendering of the glyph based on that. But if you scale the text, then we will actually generate a new edge store, because glyphs look differently depending on what size they are. And so as you scale the glyph, it will actually recreate the glyph and start from scratch. And so sometimes you'll see, I'll see folks that will animate in a thumbnail of their blog reader, or maybe they'll do some sort of effect like that. Very cool effect, but I suggest actually using a bitmap instead for those visual effects, because otherwise you're walking through the tech stack way too much. This is something that I'm looking to improve shortly. So we built the tree. Our URI-based resources are called in when they're actually added to the tree. We've pulled in the tech stack. And if you have any controls on your page, the thing to remember is that we build a unique tree for each control. And this is interesting because you actually want to understand exactly what is in your XAML, whether you use the XAML that I created for the default templates, or maybe you want to use the XAML that you've generated from your designer. You actually want to understand exactly what's in it. Because vector graphics are pay per object. And generally, it's cheap. Maybe the developer is expecting 4 paths, and maybe the designer is thinking maybe 20 paths. Not a terrible difference. But let's say that you have 40 ghosts flying around, then you have a difference of maybe 800 objects. So set goals, and be very clear between the developer and the designer on what we're expecting, when, and where. So in order to set these goals, how many people are designers in the audience, actually? Raise your hand. How many of you guys are developers? Oh, okay. And how many of you guys wear 2 hats within your company? Like, yeah, you're futzing around in Blend and you're creating the graphics. Okay, so I'm sort of more of the latter. And when I think about how to build our startup goals for our benchmarks, I think about how many objects do I want on a page. If I think about that, I can sort of start prototyping. And I can figure out how many controls am I expecting on a page. Am I building an IRS form? Am I building like a data grid? How many controls, actual controls, are on that page? And for each control, there's going to be elements, states, storyboards. Everything's an animation. And you can slim down everything depending on how you build your tree. But with clear ideas of how many objects are on a page, the designer and the developer, or those of you who wear both hats, have clear ideas of exactly what to build and what the limitations are. If we're giving free rein to designers, sometimes it will actually hurt the result in the end, because it's little cost to actually make that ghost look really, really cool, but it actually hurts the developer in the end. Because we've skipped that step. Remember that Silverlight and WPF have that shared assets thing between the designer tools and the developer tools. We use the same assets. We both have XAML. But if you're generating, what we lose within that is we lose the step of proofreading and the developer actually hand tooling and hand refining. So now it's on the designer and the developer's shoulders to proofread their XAML, prototype, and in advance set their goals together. Less is more. And always know what is inside. One of the tips that I have for when actually building tools is often people will think that your template has to be a one-size-fits-all. And that's not the case. You can actually save a couple of elements. Let's say your hyperlink button. You can save your template to have fewer objects if you have a different style for text hyperlink buttons versus image hyperlink buttons. And because we build a unique tree for each control, this actually incurs no extra cost by writing these 2 unique styles. The states versus parts, I would generally just say always veer towards states unless your part is interactive. So, for instance, focus, it's a state, it's just a visual effect, but your part is actually a slider thumb. You actually want to handle pressed or handle hover. these are actually interactive states within that part. And so part always veer towards states, and you can actually minimize the weight of your controls. And again, try to simplify your XAML. So the tips are, designer and developer, sit down together, set those goals. Define a startup goal, and then define your client's machine. And once you have your client's machine, you can actually prototype and then run on it. Got those two switched. You can do it either in each order. And then, of course, comment and review your XAML. And so, yeah. Last week, I got a call, and it was basically really emergency, we have this application, it's really slow. Okay, can you send me the application? Oh, no, it's 40,000 lines of XAML. Now, if you can't send it to me in email, the chances are that your user can't really download it either. So tools can't guess your usage. And this is something that used to happen, which was the designer would create it, and then the developer would hand create it again. And the tool, if it's outputting directly your XAML, and you do something like copy and paste a bunch, and then you save your work, and then you go back to it, and you edit it, Blend is very good about saving your work just as you left it, which means that if you accidentally made a mistake, or you accidentally copied and pasted a bunch, Blend won't actually optimize that out. So this is what we saw in the XAML that was sent, and this is straight out of Blend. There's maybe, I don't know, 20 keyframes in there. I don't know really. These are the ones that are unnecessary. And you can actually write a little script. I think eventually we'll end up writing a little script, but don't wait on me. Just get the stuff out. Watch for bloat all the time. Code review your XAML. It's really important. This is something else that we saw, 15 frames of animating from the same value to the same value. That was ridiculous. They were animating opacity too. Anyways, yeah, get it out, cut it. And so if you start using FTP to copy your source around to me or to anybody else, you already have a bad side. So the tools can't guess your usage, and it's always on our own shoulders to make sure that we don't bloat our code, and that's true of XAML as well. So we give you a lot of power there with Silverlight. We give you the ability to draw 60 frames per second. We give you the full control of the UI thread. Remember that you can also shoot yourself in the foot. What I like to think about is my car. Yes, the Performance PM has a hybrid. And basically, the best thing about my car is that when it's stopped, it turns off. And that's how your application should be. When it's not doing anything, it's just displaying text, there should be no cha-cha calculations in the background. Ashraf is our graphics architect, and he helped review the slides at the beginning, and he actually covers everything in our talk and a lot more in his book, which is coming out in March. And there's quite a few talks that actually we'll be covering. I gave a plug to Karen Corby's talk on specifically the control story and how to build better controls. Eric Schmidt and Jason Seuss will be talking about the Olympics. There was a lot of performance work within that, and you can ask them questions about our workflow there. Quite a few blogs. They'll be linked again back into the slides that are available publicly. And I want to end it with some great news. So we actually fixed a whole lot of bugs in Silverlight, and wanted to just give you a couple of highlights. So I have a Mac, and I'm actually required to test everything to make sure that the hardware performs the best on both Mac and Windows. And we got a lot of news that our managed code wasn't performing as well on the Mac as on Windows. We found the issue. It wasn't an easy fix, but we made the fix and we got it in, and so that actually has been mitigated. So try it out. Tell me how you feel. We've gotten a lot of positive reviews thus far. We actually mitigated the startup cost for the entire framework, largely reaching our goals for this version. I actually slimmed down the templates because I was getting a little frustrated with the XAML bloat myself. And I actually was able to reduce our startup time by around 30%. And so you too can look at this and find it as inspiration to write better control templates. The data grid is now virtualizing their columns because it will improve their scrolling speed. We had a whole slew of optimizations within media. I don't know if you saw, but look at this. I mean, we're spending 6% of your CPU actually on decoding video, and it's almost full screen. I mean, I'll actually show you what we used to have. It's in my slides, but it was usually around like 16%. We almost halved, or actually more than halved, the decoding of media over from Beta 1 to RTW, which is a huge win from us. Yeah, it's great. The second thing we did, just went through the collections, started reducing boxing, memory allocations. Got some random, like I didn't think anybody would notice this, but we actually got a couple wins there. And we reduced allocations for the brush textures, and there's a whole lot more that can't even fit onto the slide. So positive note, if you report bugs and you find a performance issue, I'd be more than happy to look at the app and see what's going on within the platform. Of course, I ask for you guys to debug it and do due diligence too. Please fill out your evaluations, of course. And lastly, the session is recorded, and there's my blog. I'd be happy to take questions. Thank you very much for coming. So let's see. We'll stick around for questions. We're asked to use the microphones, so if you want to queue up at those, I'll let the large influx of people. Any questions? I think we got one. Okay.
For the paths, shorthand versus longhand, which is better?
The mini language, so the question was between the mini language and the full out, like creating a new path and manually creating each segment. Right. Within Silverlight, we actually optimize the mini language so that it's just in a stream binary based format. We don't actually create the full tree. If you create the full tree manually, we'll expect that you animate the figures and stuff. And so we'll actually do the work to create all those objects. If you use the mini language, we'll create fewer objects, and it'll probably be a little bit lighter weight overall. So yes, mini language, if you
in the hyperlink button appeared to have disappeared in RC0. Is that intentional, or is there any workaround other than writing your own class?
Right, so I removed the text wrapping feature, the text wrapping property on the hyperlink button because it didn't work, and because it's actually a control. So in order to actually have a wrapping text block within your hyperlink button, just create a text block within the hyperlink button. And you can actually probably animate in and out the underline yourself.
Create it add it to the hyperlink text object, or just write your own control that mimics a hyperlink button?
You can probably just copy out the hyperlink button. I think there's some tools that you can use to strip out the generic.xaml. And if you copy out the original hyperlink button, you can actually, I think it's you want to go through the text blocks and just change the text wrapping on the text block itself within the template. Does that make sense? So you want to copy the visual tree and set text wrapping onto those text blocks. The API was WPF incompat, which was the other reason. So it didn't work, and it was API compat issue.
Thank you.
So, yeah, go ahead.
We were writing an application for Mesh, and we were finding that we only had two threads. We had the UI thread, and we had another thread. Mm-hmm. Are there any plans to get give us more threads, maybe in IE8 or something like that? Or do we already get more threads in IE8?
In IE8, I don't believe there are any plans to change that within the browser.
Because there's a hell of a lot going on in this whole dev environment that we're packing in there. So
yeah,
just two threads is pretty low.
I think even though the IE browser might not actually afford it, the different plugins within IE can actually afford a multiple thread. So, for instance, Silverlight creates its own thread for media decoding. I'm not sure what platforms you guys are using, but it should be able to host within it. I can get back to you on that question.
Okay, thanks.
Okay. Yes.
Hi. I've noticed within some of the demo applications that, from the Silverlight site, as well as our own in-house Silverlight apps, some really large memory footprints. So I had a question as far as, is there any recommended resources for memory optimization techniques in Silverlight out there? Because other than forcing garbage collection, there's, we've just a hello world, seems to add 40, 50 meg to IE, just. Oh,
no, that doesn't seem normal.
Yeah.
So I haven't seen too much of an issue with our memory footprint.
Well, this is virtual as well as actual set memory is what we actually base performance on. So even some of the demos off the site have been up to like 500 megs.
I could see that the demos are often not optimized at all in terms of their bloat for XAML, and I could see that having an issue. If you're seeing large issues with Hello World, that actually sounds irregular.
Yeah.
In terms of tools, you were asking about tools. I think the first one would be, there is nothing publicly available in terms of measuring allocations within Silverlight. I am actively working on that problem right now, but there's no news. What I suggest is actually minimizing the bloat within your XAML and just reducing the number of objects created. I will take your feedback and send me over the application. I'd be interested to see what's going on.
I'm using standard Silverlight SDK, compiling just a standard template, Visual Studio 2008, running it. It opens in a browser, and I have a browser that's 60, 70 meg right off the bat, and then when I start adding controls to it, it can go up to 90 meg. So it's a big issue because we're actually also embedding a browser in a C++ frame and doing some testing that way too. So, but memory footprint size is a big issue for our company. And
yeah, so I think the numbers are slightly different from what I've seen, and I'd be happy to take a look and see what's going on. It might be that we're actually loading more assemblies than needed. That might be. Okay. I'm just taking a wild stab in the dark.
All right. Thank you.
Yeah. Strike.
Hi. When you use visibility.collapse, is it more efficient than changing the opacity to 0 as far as memory usage and
that's
loading things?
It's a great question. So opacity versus collapsed. Opacity will actually still lay out and still walk through that area for dirty regions. If it's collapsed, it will not. And that's actually more performant. So collapse will not walk through layout, and that's always better if you're collapsing something. Yeah.
All right. And also, when you go from collapse to visible again, is it a higher cost than just going opacity 0 to opacity 100?
Yeah. So what's occurring is when we go from collapsed to visible, we're actually going to incur the layout calls of the measure in a range. Whereas for opacity, you're just changing the amount that you're blending those colors. To tell you the truth, I don't know, but I know how you can figure it out, and that would be from XPerf. So I think it would depend on the complexity of your tree, whether layout would be more expensive versus opacity, and the way to do that would just be to prototype your app and then run it through XPerf and compare the numbers of how much time is spent or the frame rate drop.
Thank you.
Sure. Yeah.
Are we going to get a virtualized list box anytime soon?
Are we going to get a virtualized list box? So I'll put your feedback in because it's always great to see what people want us to build. There's a whole series of controls that people want to see Silverlight build. And I don't believe that there are any plans announced, but I'll take it for feedback on prioritization. Yeah. Sorry. Last thing is whether you too can build a virtualized list box. I think that would be another great question. So right now, Scroll Viewer, we were trying to get the controls out as fast as possible. In fact, we actually shipped 2 weeks ago. So in lieu of that, Scroll Viewer is not set up to actually write. Our built-in Scroll Viewer is not handling virtualized list box. But what you can do is use a data grid with one column, and that's a quick and easy hack for actually using it. I wouldn't be surprised if the community actually turns out a sample quite soon. It's a long answer to a short question. Yeah.
How much of what you presented today also applies to WPF?
How much of, well, so our graphics pipeline is pretty in sync. We try to actually write our property engine, our layout engine, but our media stacks are pretty different. When you think about optimizations, most of the same rules apply. Our stacks are different, but you can watch that. WPF actually has access to F1, the VS profiler, and so you can see in detail exactly what's going on. So a good chunk of it, yeah.
Okay, thank you.
Sure.
Question about, I have a question about data binding. If you have any tips on debugging that. Currently, I do that by creating empty value converters and setting them on the binding expression. So currently, it's a little bit of a black box.
So is your question about optimization around that? Or?
Yeah, optimization. So if I have some performance issues that I don't think are related to graphics, how do you go about to debugging?
How do you go about debugging it? I think you can actually, our data binding system is largely through the property engine, and I think you can actually profile it and get basic information as to where the time is going.
Using XPerf.
Using XPerf. You can also, one of the blogs that I linked was Hamid's. Where we go? Oh, dear. Okay. Hamid is our data binding PM. Was it there? It was there, right? Yeah, there he is. He's second from the bottom. Check out his blog. Post out whatever your issue is, and we can look at it if XPerf doesn't show something up.
Yeah, thanks.
Sure. And middle.
One of the common requirements is to overlay Silverlight on top of Virtual Earth. Are there any best practices that you are planning to publish? Because it's a very common scenario that...
It's a great question. I haven't thought to actually write a best practices, but things off of the top of my head would be largely reduce your frame rate because you're going to be blending every frame, right? Because it's windowless and transparent. And then try to make your app as small as possible. Like, don't try to overlay areas that you don't have to, because you're actually reducing the size of the blit. So those would be my two key things. I think beyond that, with transparency, we found that even media and even animations can perform quite well with transparent plugins. The key thing is just to remember to test your application on a variety of hardware, because you're adding, it's just a little bit more complex.
Okay.
Does that help? Sure. Yes.
Is it possible to draw to a bitmap and then use this bitmap as an image? Like to have a XAML that is rendered into a bitmap rather to the screen?
Yeah, the feature is called Render Target Bitmap. Silverlight does not have that, and we're looking into it for future.
Because for optimization, that's a great tool.
Yes, agreed. Yeah. Yeah, I'll look into it. I'll add your feedback. Thank you. And lastly?
Our company developed a WPF application which is using media control and media element control and processing some frames through bitmap. Is it possible, or something like that, is it possible with the Silverlight 2.0 RTL bits?
So the question is to actually take the media and render some of the frames into a bitmap. Is that correct?
Right.
And you want to do this during the runtime?
Correct. but not for every frame, for some frames.
I see. My guess is that the way you would do it in WPF was to use the bitmap APIs of render target bitmap, like the gentleman just asked. No, those capabilities aren't available in Silverlight. That is an interesting scenario. I'll take it back. I think what you can do is you can decode your media to a certain frame, but you would actually have to have multiple instances of the media for that.
Unfortunately, it doesn't work because a variable per frame rate, which we are getting from Silverlight.
Yeah, it wouldn't be an exact location, unfortunately. Sorry, it wouldn't be an exact frame that you would end up targeting. So.
Right, it wouldn't be even exact time because it's not time fidelity is also violated.
So you're generating thumbnails, just to understand your scenario a bit more, like you're generating thumbnails for the video?
We are taking some timing top of media which we are displaying, and in a certain time we got to have whatever bitmap media is delivered to the browser and process it somehow.
I see. Yeah, interesting scenario. I'll take it back. We'll see if we can enable it in the future.
Thank you.
Sure. Okay, thank you very much.